A modern 2,000-ton injection molding machine requires a foundation of C40 high-strength concrete just to keep from cracking the floor beneath it. Early manufacturing facilities were built around this kind of brute force mechanics, relying on pure tonnage and intense human labor to push parts out the door. Today, that tonnage is merely the baseline for entry. The actual margins, the difference between profit and loss, hide inside unrecorded milliseconds. This chart illustrates the financial threat of cycle time drift. The flat baseline represents a target speed, say 12 seconds per part. The diverging line shows what happens when a machine subtly slows to 12.5 seconds. An operator might not notice the delay, but by the end of a production week, that tiny lag compounds into a massive gap of unmade parts and lost revenue. When a facility relies on manual logbooks, human estimates mask these small slowdowns. The plant ends up paying a subjectivity tax because the tracked data fails to capture the millisecond-level inefficiencies that precede a machine failure. To offset those structural losses, operations must hit highly specific operational benchmarks. Facilities target a machine utilization rate, the percentage of scheduled time a press is actively producing parts, above 85%, and a first-pass yield of 98% to eliminate scrap. Managing these precision assets through manual, filtered data creates what Robert C. Hansen calls the hidden factory. It allows technical debt to accumulate unobserved, eventually turning an unmonitored injection cell into a fiduciary liability for the organization's leadership. Building an integrated cell starts with the drive system. While hydraulic machines offered high force for a lower initial investment, all-electric and hybrid systems provide the energy efficiency required to recoup costs in high-volume environments. These electric systems measure actual conditions and adjust in real time. Through these closed-loop controls, the machine maintains a positional accuracy to within 0.2 of a millimeter. Inside the press, the tooling has to match that exactness. High-volume precision munds require an SPI Class 101 mold. These molds are forged from premium hardened steel, designed specifically to endure the extreme physical pressures of over 1 million consecutive injection cycles without degrading. You can find this level of hardware in top shops globally. Mold makers worldwide use the exact same 5-axis CNC machines and modeling software, meaning the ability to cut tight tolerances is no longer a regional secret. Because elite machinery and steel are globally accessible, the competitive edge shifts. Profitability is determined by how flawlessly a manufacturer manages and protects those assets during production. That management extends to how parts are handled. Relying on human operators for machine tending introduces fatigue and inconsistent cycles. Integrating collaborative robots, or cobots, directly into the cell removes that physical variable. The cobot executes part extraction, visual inspection, and deburring continuously. By automating these steps, the cell permanently locks in its target cycle times. Tying this physical precision together requires a digital intelligence layer. Plants deploy overall equipment effectiveness, or OEE, software platforms to monitor machine availability, performance, and quality. This schematic traces data capture via edge gateways, hardware nodes at the machine level. They connect legacy machinery directly to the cloud, pulling raw data from programmable logic controllers, bypassing human input. Integrated computer vision automatically records the exact millisecond defects occur, providing undeniable visual evidence. This live digital link synchronizes millisecond-level machine diagnostics with the actual maintenance execution happening on the factory floor. Up in the boardroom, this direct operational technology link gives the C-suite something invaluable: absolute machine-validated truth. Live visual intelligence eliminates the context gap between the floor and the executives. Management can review specific diagnostic video rather than relying on subjective excuses about material variability to explain a drop in throughput. This transparency establishes yield integrity. In this environment, the primary deliverable is the guaranteed functional life of the press fleet, protecting the capital investment from the technical debt of unrecorded wear. This state of balance is the value fulcrum. It is the exact operational sweet spot where intense technical capability perfectly aligns with absolute digital visibility. Reaching that integration is the ultimate multiplier of enterprise valuation. It is the defining line that separates legacy warehouses from elite, hyper